Good afternoon, good morning, good evening, wherever you are in the world. Welcome to another LIDNUG presentation. Little bit of an odd one out this time, and one which we thoroughly hope that you're going to enjoy. I've lost count of how many times this is, but we have Micheal Kenedy from Developmentor back, and he's going to teach you some Python from the point of view of the C# developer. As usual, thanks to our sponsors, Oxweb, Telerik, Pluralsight, and any others that are in there. You should all know these by now, off by heart, hopefully, but for those of you who are new and you don't know any of these, you can contact us at info@lidnug.org. or you can get us on twitter.com at LIDNUG, facebook.com/LIDNUG, youtube.com/LIDNUG, and the bit.ly/LIDNUG link will take you straight to our LinkedIn page. Again, for those of you who are new, this session is getting recorded and it will be up on our YouTube page within approximately 24 hours of us finishing this session. Coming up this month in March, we have on March the 20th a LIDNUG and Developmentor session with Brock Allen, and he's going to take you through the internals of security for ASP.NET applications in the shiny new toy that is Visual Studio 2013. Then on the 27th, we have LIDNUG and Winterlect, and we have Mr. Dave Baskin, who's going to take you through the fundamentals of AngularJS directives in .NET. Please note that at the moment, some of our events may be rescheduled due to current circumstances with staffing and people to run these events. We hope not to change things too drastically, but at most, a lot of things may be pushed forward an hour or two. We have Micheal Kenedy up. He's a LIDNUG veteran. He's co-creator and lead developer at Learning Line Developmentor's online training, and he's the author of several other presentations and courses on JavaScript, Python, MongoDB, and quite a lot of other stuff. So, without further ado, Micheal, take it away.
Thanks for the introduction, and thanks for having me, you guys. And I hope you enjoy this talk. I think it is going to be a fun one. Let me switch over here to my computer. All right. Well, that is for later. Okay. So, does everyone see my screen coming through okay, Peter?
Yep, it looks as though it is.
All right. Brilliant. Let's get started. Okay, so as you heard in the introduction, what we're going to talk about today is Python. And instead of just saying, hey, Python is a cool language, this is something you should go learn, right? There's a ton of cool languages. Go is cool. JavaScript and Node.js is cool. There's a lot of things you should go learn. But what I wanted to bring to you guys, a revelation or something that struck me when I learned Python was just how similar it is to C#. By the end of this presentation, I think you will all be blown away by how similar Python and C# are. And I think there's a lot of benefits to that. One is it makes it easy as .NET developers for us to get our mind around. Yeah. So thanks for that. Thanks for the mute. Yeah, no worries. Thanks for the mute. So I think it helps you get your mind around the language because you already understand all of these concepts super well in .NET. And it's just like, oh, this is how you do that thing in Python. One of the challenges of learning a new language is I used to be able to do all this excellent stuff. I used to be able to access databases. I used to be able to write web services. I used to be able to do web pages. I used to be able to, whatever it was you're trying to do, all of a sudden you've got to relearn what you feel like you already know. So with Python and this really close similarity between C# and Python, I think you'll find a very comfortable language here. So why are you interested in, learning Python at all? Well, if you look at the tech world around us today, the developer world, we're seeing an explosion of different operating systems, a fragmentation of all the various tooling that you can use, a big push into the open source world, right? Open source has been around for a long time, but is really just going strong these days. Large companies are making good money off of open source. Many people have GitHub accounts and are doing their own projects and contributing to other projects and so on. Well, .NET is great for writing Windows applications or writing web apps that run on Windows servers, but what if I want to write an app that works equally well on, say, Windows and Linux and my Mac? There's not that many choices, right? There's Java, sort of, it's one of your choices, but you'll see that Python is a really good choice for that as well. So there's a lot of reasons to learn Python, but let's go ahead and get into some of the details here. So the first thing that we're going to do is I'm not assuming that you guys know Python. I'm going to give you a quick introduction to the language. And the language is really, really simple in many ways, but is also rich and expressive. So it's quick and easy to learn. You'll see, like, in about 10 minutes, we'll see most of the stuff you need to know to understand the code samples for everything that's going to follow. Right? Of course, how you're productive with it and the best practices and all that, that gets really interesting. And the libraries you can build upon get really interesting and take some time to learn. But the language itself is pretty straightforward. Just like, when you learn C#, the C# itself is actually quite simple. It's learning .NET, WPF, ASP.NET, MVC, all these things, that's where the work is, right? Similarly with Python. So we're going to do a quick demo of the Python language just so you guys have a little bit of experience, and everything else that I show you, you'll be able to read and make sense of in just a few minutes of exposure. Then what we're going to do, we're going to look at the things that are great about .NET. So if you guys had to come up with a list of all the things that are awesome about C# and .NET, the things that you would say, look, it would be super painful to go work in some other platform or some other language without Entity Framework, or pick your favorite thing of .NET that is super important to you, or your set of things. We'll see that I came up with a list that I think most people would more or less agree upon. What you'll see is that in Python, almost all of those features exist in some manner or another. Excuse me. So after you sort of made those connections, we're going to go through each of those .NET features, and we're going to explore Python through that lens. Right? So we're going to talk about LINQ, and we're going to see what Python has to offer in terms of something like LINQ. We're going to talk about Entity Framework, and we'll see what Python has to offer in terms of things like Entity Framework and so on. Okay, so first of all, what is Python? Well, Python is a high-level programming language, like Ruby, not too unlike .NET, C# rather. It's interpreted, however, most of the time. The default implementation of it, the default runtime, if you will, of Python is interpreted. But you'll see that it doesn't have to be interpreted. You can get an alternate runtime that actually does JIT compilation. We're going to dig into that, the different runtimes you can choose quite a bit later in the talk. But there's actually some interesting choices you can make there. But you should probably mentally think of it as an interpreted language. It's an object-oriented language, very much so, especially Python 3. There's two versions of Python. There's Python 2, which you'll find in the flavor of 2.7 these days. And there's Python 3, Python 3.3 or 3.4. 3.4 is just about to be released, and so on. And Python 3 especially has been sort of rewritten in an incompatible, backwards breaking changes sort of way to be more object-oriented and to clean up the language. So especially Python 3 is object-oriented. The next statement kind of catches people off guard sometimes. It's a strongly typed language. Okay, so things in Python have a type. They have a type hierarchy. They have this concept of inheritance. If you go to an object, you can ask it what type it is. There's a type operator like type of in C#. However, when you look at the code, all the variables, they don't have types. Right? The method arguments don't have types. It's a dynamic language, and the way you work with the objects is through dynamic semantics, and the way that you interact and declare your variables and so on is all dynamically, like sort of more or less untyped. but the things the variables actually point at, they have types, right? Just like in .NET. So that's pretty interesting. You'll see the syntax strongly emphasizes readability. Okay, so in .NET and C#, there's quite a bit of ceremony around various things that you do, right? If you want to declare a property, there's like, 4 to 6 curly braces you've got to define and things like that, right? So we'll see in Python, they take away a lot of that stuff that is not really necessary. And at first it's kind of shocking, but then when you do it for a while and you go back to .NET, you're like, why am I writing all these curly braces, parentheses, separators? It's just not necessary. So it's a really clean, simple syntax. We'll do a lot of comparisons of here's the .NET code and here's the Python code. And you'll see that the Python code is often shorter. Sometimes it's like a third the amount of code you've got to write in .NET to do the same thing. And some of that has to do with this emphasizing readability, and some of it has to do with just other choices they make. There's a packaging system, just like in .NET we have assemblies and libraries. You can pass them around, you can kind of add reference to them. You can do similar stuff with that in Python with modules and packages. Okay, and finally, you'll hear this term, even though I put it at the top, I'm saying it last, sorry. You'll hear this term, batteries included. So when you're learning about Python and you're exploring stuff, you'll hear batteries included as sort of a selling point of various frameworks that you might build upon, Python itself, things like that. And what that really means is there's a large standard library. There's a large base class library in .NET terms. Very much like you can go to .NET and it's easy to parse XML files or talk to web services or whatever, right? Very similarly, Python has stuff like that as well. So in the community, you'll hear them say batteries included to sort of say, look, we're really emphasizing the fact that a lot of this stuff is here for us. Okay, so the one thing that is super different, maybe not the one thing, but the thing that is most different to .NET, C#, VB, and so on, is there are no like curly braces that define blocks of code, but rather Python uses white space to define blocks of code. So here you can see a bunch of different colored blocks, and each color represents like a code block, a syntactical code block in Python. So here we're defining a method. We just say def some method, colon, and then you indent. And you indent 4 spaces, not 3. You indent 4 spaces, not tab, 4 spaces. And as long as you're indented 4 spaces, you're in this method. If you drop out, like here we unindented to this def, now we're defining a new method. All right. Similarly, we have an if statement, colon, space, 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 space. Here's some stuff in that block, unspace, right, unindent, you're in another block, else, and so on. So this seems a little bit unusual when you first see it, and it definitely catches you off guard. But what you'll see is when you start working with the editors, the IDEs and tools like that, they make this very natural and very easy, and a lot of times it's actually nicer than what's going on in C# because it sort of enforces a common way to indent and define blocks and so on. Right, but you got to be aware that that's what's happening. So white space matters. So let's just do a really quick demo, and then we'll move on to talking about the parallels between .NET and Python. Okay, so I'm going to switch over here to this IDE. This is my favorite IDE. I'll show you another one in a little bit. This is called PyCharm, and it's being hidden by this little like remote control, screen control thing. I'm not sure if you can actually see the title, but PyCharm, PyCharm. This is from JetBrains, and JetBrains is the same company that makes ReSharper. So imagine, how cool would it be if the guys who make ReSharper went and built their own IDE from scratch for .NET? Like I've always dreamed, like, well, what would it be like if there was like a ReSharper IDE for .NET? That would be fantastic, right? Well, this is what they did for Python. This is the IDE from scratch for Python, so it's pretty cool. And you'll see some other options, like I said, but I'm going to use this one for here. So let's go, and we'll make a new file, a new Python file. And let's see, we'll call this, let's call it weather. So what I want to do for you guys for this really quick demo, I don't really need to show you my name again, do I? What I'm going to show you is a simple little app that sort of predicts the weather. And it's going to predict the weather just by using randomness and whatever. So what I want to do is I want to define a main method. So the way we define methods is you just say def. I'm going to say main. Most stuff in Python is lowercase, just so you know. And then I need a block. So watch what happens. Remember I was talking about the space and how the editors help. So I'm going to say colon. I'm going to hit enter and watch where the cursor goes, right? Automatically indents 4 spaces. Because it's like, hey, you're defining the method. You need to go in here like this, right? If I do some more work, like I put a comment, and I hit enter, it takes me out because it doesn't really know, does it? But as you see, as I type real things, it will start to fill up, okay? So what I want to do is I want to call a method, define a method, call it, that returns the number of days. I could, of course, just define this inline, but I'm trying to keep like a really simple example that will show you the way various pieces work. So let's say we're going to have a method here, and it's going to return a list of days. In .NET, you might say list, angle bracket, days, or of string, close angle bracket, days equals some method call, right? In Python, you don't define variable types. You just say the variable and initialize them, and that creates them, right? Because things are dynamic, you don't need to say the type, so why would you do that? So I'll just say days equals, and I'm going to write a method here. I'll say get all days, something like that. Okay. Now notice this has got a little red mark. Just like in Visual Studio, you can say create me this function, and it will go up there. Now notice at first it says pass, because you need to have, just so the parser can make sense of empty blocks, you can say pass if you kind of want it to do nothing, but that's obviously not what we want it to do. We instead want to write a method that's going to look something like this. So let me put a little comment here. This is going to be a public list of string get all days, something like that, right? So that's what the top part looks like. Now, let's go in here and I'll say, let's define, I want to write code like this. List of string days equals da da da. So the way we're going to do that in Python is we're just going to say the variables, days equals. Now the way you define a list is like that. That's a list. I know it looks like an array. Just in your mind, you have to say it. Arrays are like lists, right? So we're going to go in here. We're going to put things like Monday, Tuesday, Wednesday, Thursday. You know where this is going. Friday, Saturday, and Sunday. Okay. So then we're going to return days. Okay, I notice when I hit enter, it just goes to the end because it's like, hey, you type return, so you must be done with this method. Whereas if I'm up here and I hit enter, it leaves me right here. So like I said, the editors are super helpful. Okay, so now we're going to get some days here, and let's do this. I want to loop over them. In C#, we would do for each, right? So what we're going to actually do here is we're going to say for, but for in Python doesn't mean what you think it means. So we'll say day in days, kind of like a for each loop. Okay, so when I say for day in days, and I want to do something equivalent to console write line, yeah? So what I want to do is console write line, because I'm still in .NET mode, but I'm going to say print, and that's the Python equivalent of that. So for now, I just want to print out the day, just to prove that I can get the days. So let's go ahead and run this. Let's see. So if I go over here, actually, just go like this. We're going to say run weather. You can see the output runs down here. Oops, it's kind of empty. Okay, that doesn't look great. Why is it empty? So in .NET, if you define a main method, it just runs. In Python, if you define a main method, it doesn't mean it runs. So I need to call it like this. It's one possibility. This is not the right possibility, but it's one possibility. And you can see it's spitting out the days, Monday, Tuesday, Wednesday, Thursday. Yes? However, if for some reason this getAllDays function was useful somewhere else in my program, outside of this file, and I try to import it, basically the way Python imports it is it reruns this script to define these methods if it hasn't already done so. But it's also going to execute that code, right? So they've got this this common convention in Python that says only run main if I am the script or the program that's running. Otherwise, just import my stuff. See, there's a question. Let me see what's going on here. Yeah, it says one, but I see. Oh, yeah, there you go. What's the name of the IDE again? The name of the IDE is #PyCharm, like that. Okay, good question. So let's keep going. So now we've got our little method that gives us days. Let's have another one that gives us a report. So I want a report for given a day. I'll just say get random report because we don't really need to pass the data. We're not actually using that data, right? And then what I want to do is I want to do something like this. I want to print out that report in that day. And in .NET, I would say something cool like this. I would say on curly 0, the weather is or will be curly 1, yeah? Right? So do you know what you do in Python? You do that. That's what you do. So except for instead of calling a static string.format, you just call .format on the string. So we'll say day, report. That's pretty awesome. I actually like this better than the .NET version, right? Format on the string rather than format on the string class. Okay, and I got distracted from this. So the convention is if there's this this variable, environment variable type thing set called __name, which talks about the name of your script or your file. We'll say if that is equal to __ main. That means you're the thing that's running, then do that. Okay, so you'll see this often, and this just means only run this method if this is the script that's running, not if it's being used as a library. So, well, I better finish writing this code before I try to run it. Okay? So again, I can hit Alt-Enter, just like in ReSharper, right? You can imagine that the ReSharper hotkeys that you know and love are very, very, there's a very close parity between ReSharper and PyCharm because it's the same guys that make it. Okay, so here's another method, and this one is going to get a random report. And this time for my random report, I want to use a class that's not part of my script. Right? I want to pull in like a base class library, kind of add reference, if you will. So what I'm going to do is I'm just going to say random here. It needs to stop. Sorry, it's trying to help me too much. Random, one thing at a time. So I go over here and it says, oh, you can import this name. So if you type like date time dot in Visual Studio, it'll say, oh, you're not using system potentially. So here, you add a using system at the top. That's what this is. So it says I can import the library or I can import the class. There's a little more flexibility in how you do what is the equivalent of a using statement in Python. So I'm going to say just import the library here. If you look here, you can see import random. So down here I can say random dot. There's a couple of things I can do. Probably the best one to use is, what's this, choice? Yeah. So choice, given an array, is going to return one of the elements randomly selected. So rather than creating a random number and figuring out which integer within the index I want to use and then choose one of those, I can just say random, not choice. But I need reports, like some sort of variable that holds these. So here's my new list. I'll say lovely weather, raining, hot, freezing, as it is in much of the US and so on. So then here I can just say from the reports, choose a random one of these things and return it. So I think we're ready to run our code. We've got our get all days, which generates this. Granted, you could do this inline, but it's kind of nice to have it pushed to the side there. A reasonable way. Now we've got our get random report. We'll call on that inner loop, and we're printing out on such and such day the weather will be whatever it's going to be. There you go. So on Monday, the weather will be hot. On Tuesday, the weather will be raining, and so on. Rainy, raining, whatever. You guys get the idea, right? So the one thing we haven't really talked about here is we haven't talked about classes. The classes are defined in a very, very similar way, and we'll talk about that when we get there. Now, notice sometimes it gives you these little squigglies, and this is not technically a code problem. It says a PEP8 error has been detected. PEP8, Python Enhancement Proposal, this is just the standard naming convention in Python. So it just says you need to do some cleanup, and I will say code, reformat code, right? Alt F8, run. So then it reformats it, just like in Visual Studio, you can say reformat my code. Okay, so there's a little example. Let's go back and look at some of the features of C# that are awesome, and then we'll sort of make our way through them. Okay. All right. So here we go. What is awesome about C# and .NET? If you guys stopped me on the street and said, Michael, give me a list of what's awesome about .NET. Why don't you go do something else for most of the time that you're doing programming, right? I still do mostly .NET programming, as you guys probably know if you've seen me on this thing, on this LIDNUG webcast before. So these are the things that I think make it amazing. And, you know, I'll read some of them to you, but I'll try to avoid reading all of them, right? So for each loops. Right? The fact that we can just go to a collection and just go, let's just go through every one of these and work on it. And you don't have to go, okay, well, make sure we don't overstep the bounds and index into it and then potentially upcast the things that come out of the for each loops handle all of that stuff, right? So for each loops make coding and reading code much cleaner. Properties, you know, the last time I wrote a getter and a setter, you know, it was a long time ago when I was doing a lot of C++. Right? Languages like C++, getters and setters are necessary because you might need to do validation or transformations or expose computed values or things like that. But in .NET, we stopped doing that for the most part because we have this concept of properties, and properties let you sort of consume data in the most natural form as fields and values, but generate them and validate them just as you should for data encapsulation as methods, right? So properties are awesome, and I hate to have to go back to write getters and setters. Let's see, the ability to go and just say add a reference, like just grab a library and say, this, I'm using it. I don't want to have to import the header, the lib, you know, make sure the DLL is there or the static type library is getting folded. Like, all that stuff that other systems use is just super painful, right? Add ref, just the super easy way to import, export, and share classes between libraries and reuse code is so nice in .NET, and that's sort of the whole add ref style of working. NuGet, you know, we can go to NuGet and we can basically add ref to open source project. Do you want to use JSON.NET instead of the WCF JavaScript serializer or JSON serializer? Just open up NuGet, add reference, it's like right there on the front page. Right? So the ability to sort of import and use other projects has just exploded since NuGet came out. Right? Entity framework, like when was the last time you guys wanted to write SQL by hand? I've written plenty of apps that have like 5,000 lines of select star from this, select star from that, and convert it to classes, but it's not helpful, it's not productive, it's error prone, there's just a lot of problems, right? So ORMs, and especially Entity Framework, make that really nice. Okay, so you can see, as you go down this list, these are all like the top hits of .NET in my mind. What I'm going to show you is, at least for the stuff on this screen, every single one of these exists in Python. Sometimes, maybe half the time, in even better forms than in .NET. So just let that sink in for a minute. Like, here's a language that's super simple and clean, runs cross-platform, and it has all of these features, right? These are the features that sort of make .NET feel like a snowflake, right? It's super special and unique, and it's the reason we love it. Well, that's true, it is a good reason to love it, but it's not necessarily the only thing out there that has these features. Okay, so for starters, coming from .NET, I assume that if you do not have an IDE, you're probably not very happy about it, right? If you have to go back and write in Sublime Text or Vim or Emacs or something like that, you can do it, but in my opinion, it's just super unproductive for even moderately sized applications, right? The ability to refactor, to go to definition, to debug, all these things just blows away like any sort of, well, my text editor starts faster argument in my mind. So what would you use to write Python code? You've seen PyCharm, right? Well, let me show you another option. This is pretty cool. If I come over here, this is Visual Studio 2013, professional as it says right there, and I got these this free open source plugin put together by Microsoft called Python Tools for Visual Studio. And because of that, I can do this. I can say new Python project, Python application. Now, you guys all probably have heard of IronPython, right? This is the .NET version of Python. It runs on the .NET runtime, and and those things. And it's pretty cool. It does some really neat things. We'll actually talk about it. However, it doesn't give you the benefits of Python in the same sense that I talked about at the beginning. It does not give you the ability to run cross-platform code. It doesn't give you the ability to write stuff that's going to run on Linux servers. And if you're doing things like hosting, infrastructure as a service in Amazon Web Services, the price of the Linux machines are these days about 2/3 the price of the Windows machines. And Azure, the price is just the whole price, right? So if you want to run cheaper stuff in the cloud, right, well, Python's one of the ways to get there, but Iron Python is not going to help you because that's still a .NET thing. But these two, Django and Python, these are actually like plain Python. So I'll just go just hit that. All right, hello world, and watch if I run this. Let's see, boom, hello world. Just in a console app, a little console app looking thing. Right, but this is not running on .NET. You can actually go over here, if I find the right thing, go to the properties, go to the Python environment. Oops, that's not what I wanted, sorry. Go to the properties here. And you can see what interpreter to use. Which version of Python do you guys want to use? There you go, huh? Pretty cool. Now, let's go and take this code that we just wrote. Put it over here in Visual Studio, Control F5, boom, there you go. On Monday, the weather will be this. On Tuesday, the weather will be freezing, and so on. So here is a really cool IDE with IntelliSense, by the way. I mean, it's not just like messing around. So I come down here and I can say print, and there's my print with, I can see the documentation. I can open it up. It tells me what the arguments are. I can say get all days, get random report. And just print all the days one more time here, and maybe outside the loop. Right. So here you can see, I guess I better call get all days, huh? The fact that it didn't crash and it just passed this function and it did some stuff should tell you there's some really cool sort of delegate-like support as well. All right, so here's the days, right? So pretty neat. It has IntelliSense, it has debugging. I can go set like a breakpoint here. I can press F5. Okay, I can go hover over days. There's the values. So this is free, and this is pretty awesome. So if you're coming from .NET and you're like, well, I really can't give up Visual Studio. Okay, don't. You don't have to, right? But you might wonder like, well, why would I go use PyCharm if I could use this? So check out your options here. So if I go down here, let's see. If I go to the properties on this thing, for example, whoops, not that far up. Properties. You can see I've got a couple properties. I can write a Windows app or a regular app. I can talk about debugging, right? How do you want to debug it? .NET, Django, Iron Python, a couple of arguments, and I can like publish it somewhere. That's all cool. If I go to this one, and I go pull up my settings, you can see there's a significant amount of stuff that you guys can be doing here in the IDE that has to do with all of this stuff. So like, for example, if I want to go work with my Python interpreters, I can go, configure the new interpreters. Let's go and add one. I think I have some more in here. I can put them in Python. Let's see. Yeah, so for example, I could add the 32-bit version of Python 2.7. No, I don't want to make that the default. And then it does a bunch of other stuff with like isolating environments. There's just all these options that just don't really show up in Visual Studio. So, I kind of feel like this is cool, but I'm not sure I would call it like the professional Python developer tool or whatever. So it is cool though. So if you really love Visual Studio and you want to write Python, well, go get these pytools.complex.com extensions for Visual Studio, if you will, and then install them, and then you can just use Python from Visual Studio, rather. So, however, if I were doing it, I would go and get PyCharm. PyCharm is cool. It runs on Windows really well. It also runs on Mac, and it runs on Linux. So, this sort of cross-platform thing is much easier with PyCharm. And there's a community edition that's free, kind of like Visual Studio Express. And I think the official price is like $99 instead of a couple thousand. So pretty cheap. Also showed you a little bit about debugging. So Visual Studio lets us debug. It's awesome. PyCharm lets you debug. Visual Studio tools for Python let you debug. Very great, very good experience. Let me show you one feature that's kind of cool here. So sometimes you might, if I have a function def func with param, we'll just call this p, and we'll just maybe print out p, so we don't really know what we're doing with p. And down here in main, let's say we're just going to say func with param, welcome to the weather app, right? So if I come down here, it doesn't really know what p is supposed to be, right? Like I can get IntelliSense and it says, oh, there's a p that goes here, but I don't really know what it is. And there's ways to do, how in C# you can go // and it'll create the summary information. I can do that here with triple quote and say this prints whatever you send it. Now, if I call this, let's see, go down here, you can hit Control Q for documentation. So this will print whatever you send. That's pretty cool. But knowing what goes in here, because like it's not clear what you can do with this. If I go down and hit dot, it's like p dot. Well, notice they actually are figuring out. Well, the only time you ever call this function, you seem to be passing a string to it. So these are the string functions. And if it can't figure that out, there's some cool features around here where you can go to Python debugger and you can say collect runtime type information for code insight. What that means is as you debug the thing, it collects what is passed to these methods, and it goes, oh, every time this was called, a string was passed, so all of a sudden this gets IntelliSense for string, things like that. Pretty awesome. Okay, so that's probably enough IDE stuff. We'll move on. So the question just came up, how easy is it to develop a web page? Can you show us? Yes, it's easy to develop web pages. There's some really interesting frameworks out there. We'll get to it, definitely. Great question, and it's coming. Saving the best for last. All right. So everything is an object in .NET. We kind of take that for granted these days. But if you ever worked in languages like C++, where there are 5 or 6 different types of strings and there's no relationship between them, you know how painful working with things that don't have common base types and sort of a unified object structure can be. Well, luckily in Python, everything is an object as well. And just to show you, here's how you define a class. You just say class, name of the class, and instead of colon, we have a parenthesis, that's the base class, and we do a colon, and then you just define your methods in there. All right, so we'll do more of that. But in either case, like here, we're showing an example, you can override toString. Hey, I'm a document. In Python, you override this thing called a magic method, and you have 4 underscores. You go underscore, underscore, str, underscore, underscore, and people don't like to talk that way. So sometimes you'll hear people just call that understring. Sometimes people will call that dunderstring. You'll hear those a couple times because people don't want to say underscore 4 times. It kind of gets old really fast. But you basically have the same concept of overriding the toString. We already saw that for each is awesome in .NET, and in our little weather app, we did a for each over a list of days. So anything that is iterable, just like in .NET, anything that implements IEnumerable, anything that is iterable in Python can be looped over in this way. But what's sort of striking about Python is there is no for loop in the sense of the C# one. There's no indexed numerical-based looping structure in the language, period. Okay, so you almost never need it. You'll be surprised to see that you almost never ever need to know the index of day. But if for some reason you needed to, you could write this code. You could say index comma day equals enumerate, if one can spell that. And what that's going to do is it's going to return a tuple of for each one, it's going to return the index and the day. Let's see if I probably misspelled it. No. Enumerate. There you go. So I'm not actually printing out, but we could print out curly 2 here. Let's go index. All right, 0, 1, 2, 3, 4, 5. Okay. So this kind of funky structure, but it lets you kind of get back to the same thing. But the core essence of looping in Python is to use for each loops. So that's all interesting, that given like this collection, I can loop over it. But what's really neat about .NET is I can add this ability for my object to be used inside of loops, right? So here's a shopping cart, and I got to write kind of a bunch of code, like I've doubled the size of this class just so I can loop over it, but whatever, it's worth it, right? So I've got this private list. I want to loop over this shopping cart. Okay, so can you do something like this in Python? Well, yes. Let's go write a little bit of code. Okay, so call this loops, something like that. So you can configure that to stop putting your name at the top if you want. Okay, so what I want to do is I want to define a class called shopping cart. So this will let us explore defining classes as well. And in Python, you have this concept of a constructor, just like you do in .NET. So we're going to define it, but it's an under init. The other thing that's kind of different is, just like in .NET we have this, in Python we have self. But what's really different about that is it's explicitly passed. Unlike in .NET, this is kind of an implicit thing that's always around. So I wanted to declare some member variables. I'm going to call them items. I want it to be an empty list. Okay. So that statement will dynamically, as part of the construction, add items, and it will make a new empty list. Okay. And then let's add one more function. Let's call add, and this will be a cart item. Let's do it like this. I'll say self.items.append, that's like add in .NET, cart item. Okay. So let's also define this class of cart item, time almost, item. I want to define our constructor, so under init. And here we're going to say self.name. Let's do it like this, name. Then we need to put this printer up here, and we could also say price. Have this cool little resharper-like thing, let you add the price automatically. So let's create our shopping cart. So say cart equals shopping cart. That's how you basically, call new. Assume you write semicolons and curly braces. Like if I'm switching this quickly between .NET and Python, it starts to freak me out, and I start to do things like put semicolons. So I'll say cart.add. That's the method we wrote. And I'll create a new cart item, call its constructor, and it takes a name. So let's call this a CD, and this is going to be 1999. Do people still buy these things? I'm not sure. Record $17.99. Then suppose we want to be able to, like, for item in cart, print curly costs dollar curly one, like that. Okay, even do a little comma like that for formatting, I believe. Okay, I can say item dot. Notice there's no IntelliSense. It's like, I'm not so sure about this. But let me just keep going. I'll just say, all right, name item dot price. If we run this, let me set this as the startup thing. It says, no, shopping cart is not iterable. So in .NET, what do? You say, enumerable of cart item, blah, 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 and off you go, right? No, we don't do that in Python. That's too yucky. So if I just want to add this capability here, I just say define under iter. Okay? And if you have this method, just like get enumerable or whatever, then you're good to go. So I'll just say return self dot, I'm just going to really delegate over to that guy, just like I was in my C# example. So now if I run it, it should work like a charm. Of course, I think I might need a colon, comma, I can't remember. Anyway, there you go. Right. CD cost $19.99, record cost that. Pretty excellent stuff, right? So just, look at this. Compare that to the .NET version. Right? Look at those two things side by side. Which language would you rather write in if you had a choice between writing the code on the left or the code on the right? You'll see a lot of examples of this. Okay, so properties, again, properties are awesome. I already gave you the background of why you want properties, but just, they're awesome, right? We all know it. So here's a computed value that we can treat as a fixed value. So our shopping cart could have a total price. You could say, well, here's the total, and we're going to just sort of treat it at the bottom like cart.total price, right? Looks really good. Could you do this in Python? The answer you can bet is probably yes. Let's add this. Let's say def total. The way you would do that in sort of this Python standards would you say total underscore price, probably. And notice when I hit open curly, it's going to automatically put the self, and I can close that off if I want. Okay. So here we're going to say total equals 0, or item in self.items, total plus equals item dot. Notice it now knows intelligence, yippee. Okay. Return total. So down here at the bottom, I could write this code. I could say print the total price is $0. And we'll say format cart.total price. And now notice it's a function call. Right, you see the glowing yellow selected parentheses. All right, just let me show you it runs first while we do that. Total price is this. So instead of doing what they do in .NET, there's a little bit of a more funky way to do this. What you do is you add on what's like an attribute, more or less. You say at property. When you say that, all of a sudden, if I go back and type this again, .total, you can see there's a little p. If I hit enter, it's not a function. If I try to call it, it will actually crash and it says numbers can't be executed, basically. Right? Okay, so we have these properties. Now it gets a little funkier when you want to set the property. So if you want to say def total, set total price value. Let's just say pass or anything. We would say at total price dot setter. Okay, and that lets you set the value. So the setting part is a little kind of insane, but the getting part is super easy. Okay, so yes, you can do it in Python. Very nice. I see there's 2 questions. Let me see what those are. In C# for a total, I'd say get item sum. Isn't there a simple link way to do it? Yeah, there's definitely a link way to do this as well. Yeah, you can definitely do it. Off the top of my head, what is the simplest way? Oops. I'm not sure if there's exactly what you're asking for, but items dot sell dot item. I think you might need to get into the map reduce sort of stuff. Yeah, it's probably not worth going into. Yeah. We'll look at the link stuff in a little bit, okay? Let's see. Is self and the P identical to this? Yes, self is this in C#. Absolutely. Okay, next one, anonymous types. So anonymous types are pretty awesome. They let you work with sort of projections from databases and transformations of objects without the need to go and create new types, right? So if I've got a database with 10 columns, and I map that to a class, and sometimes I want the first and third, sometimes I want the third and fifth, and sometimes I want the first, second, and third. Like in old C#, you would have to write 3 classes that represent each mapping, right? So obviously that was crazy. So when they came up with LINQ, they said, well, we're going to come up with this anonymous type that lets you just do like this projection here. Just to keep it separated from the data access stuff, which we'll talk about later. We'll look at it separately here. But basically, you can do exactly the same thing in Python. You don't quite get the same intelligence, but other than that, you get the same thing. So first of all, let me try to write a little bit of code here that looks like, we'll call this anon. So let me write a little bit of code that looks like this. Make it run, just do the right one. There we go. So I can create, there's this cool way to work with dictionaries in here. So I could have, let's call this pet1 equals, so we can start with this. You could say there's this dictionary that has a name, and the name is going to be Fluffy with an L, and its age, it's very JSON JavaScript-y feeling, yes? Is going to be 17. That's an old Fluffy. I could print out pet1. So if I run this, you can see there's this name and age. And this looks almost identical to the output from C# when you print out its anonymous types as well. Okay. There's a little cleaner, maybe more explicit way to do this. I could say pet2 equals dictionary, call it constructor, and I could say name equals Fluffy, age equals 17. And this set of keyword arguments is what it's called, will actually generate the dictionary just like it does above, right? This is the key, this is the value, and it creates it. So I could also say print pet2 and run that, and you see obviously they're identical. I could print out the pet2's name like this. Name. It's kind of cool, it gives me intelligence there, yeah? So let's run that. There's Fluffy. But what I can't do is this, which is what you get in anonymous objects. I can't do pet2.name. Because no. Dictionaries don't have .names. What are you, crazy? I want to add that. So I want to create a third pet that is similar to this dictionary that has this capability, this like final capability to treat it as if it were just a property of the object. And so in order to do that, I need to steal a little bit of code here. So we need to define this one class. And while technically it's not built in, it's quite easy to add it. So if we add this thing with a C, we get this class called a non-object. So I can change this down here, and I'll explain it to you in a minute, which we'll call, let me also print pet3, and then I'll print its name. So we run it, you can see there's pet3, and then there's the name. I could even go age +1 or something like that, right? 18. So I can work with it just like you would like an anonymous object in .NET. But what did we do? Well, we defined a class that derives from dictionary, and we just said, you know what? Instead of using dictionary's implementation of get attribute, which is like field access in Python, I want you to actually just go to the dictionary and pull out things with the name of the field you're trying to access. And when you set a value, just put it back in the dictionary. Sorry about the pink. I know it's a little hard to read. Okay, so with those like 3 lines of code, we've added anonymous objects to Python, which is pretty cool. We'll see that come back when we get to the database stuff. Let's go back. Okay. So another thing that's really neat is Lambda expressions, right? The ability, or even just delegates, the ability to pass a delegate. Here you can see we have a find method, and we're passing in a delegate that lets you take a set of numbers and filter them in some way or another, right? So only the numbers that match this predicate we pass in actually get returned. So here you can see we're saying, I want to find the numbers that are divisible by 11. And the output is 0, 11, 22, and so on. So what can we do in Python? Well, let's go and look at that. Delegates. Now, they don't call them delegates in Python, but just to keep the .NET analogies clear, I'm calling them delegates. Okay, so suppose we have a function that takes this delegate. So we'll have a def special numbers, and it's going to take a, call it a predicate or a test or something like that. And so we'll say for, here's where you might want that indexed for loop, or the numerical for loop. But I'll just say for I in range from 1 to 100, say if predicate, you could type parentheses, it won't hurt anything, but it's also not necessary. Say yield I. So another thing that's really cool is Python also has yield, like .NET has yield return. So I could have another method that says evens, and it takes an n, and it returns n mod 2 is 0. Okay. So then down here I can write a main that says nums equals special numbers, and evens, we'll just pass in that method, and then I'll say for n and nums, print and I kind of want to do a console write, not a write line, so it goes across. So I could do like this. I could say end equals, comma. Okay, notice this is a little unhappy because it wants 2 spaces, not 1 per, to separate methods. All right, so let's run this now. Right click, run delegates. Of course, I forgot my little convention, didn't I? If I write a code snippet that generates this, usually, but this machine I don't typically work on. I had to set up a Windows 7 machine for live meeting, so I usually work on my Windows 8 machine, which has that configured. All right, so there's the even numbers between 0 and 100. Right, but just like .NET, they said, you know what, that's old school, don't do that, guys. What we want to do is we want to be able to just take this little statement and stick it right in here as a lambda. So we can do that too. We can say lambda, and given n, colon, we want to go, this time let's find the evens. Okay? Actually, just because n is used here and here, I need to use a different one, like x or something. Okay? So let's run it again. Boom. Well, I got everything but the things divisible by 3. Okay, equals 0. Let's write it correctly. There you go. 3, 6, 9, 12, so on. Pretty cool, right? So lambdas are one of those things that it's just magical in .NET, right? They make so many things possible and simple. Well, here they are in Python too, and they have almost the exact same syntax, right? Okay. So yes, we can write the same code. Let's keep going. All right, so one of you guys asked about LINQ. Let's talk about LINQ a little bit. So LINQ is one of the crowning achievements of C#3, along with Lambda expressions, I might add, and extension methods. Those 3 things together are just, you know, they make a world of difference. So here we've got a set of people, and we can do things like order them, we can filter them, and so on. Let's see what Python has for us here. So I'll create another thing called LINQ. It's not called LINQ in Python, but that's the analogy you guys will have. So let me create that. So let's define a class of person. And it's going to have a constructor. And here we're going to say self.name equals name. And add that as a parameter. Yes, don't need that. And we'll just say age. That should be enough to make this work. Okay. Then let's define some people here. It's going to be a list. So we'll make a list here. And then we need to put some persons into it. So we'll have Jeff with a capital E apparently, and he'll be 21. We're going to have Zoe, she's 30. We're going to have Mark, he's 42. We're going to have Ted, he's 50. And Bill from his excellent adventure, and he's going to be 52. We'll have Sarah, she's just a kid, she's 7. Okay. So just let's make sure we know what we're working with here. We'll print out people and run that. So notice, first of all, that we've got this crazy looking thing here. It actually gives you the in-memory address of the person object. So we have under main.person, right? That's the name of the file as far as it's concerned. And there's the stop person class. So I kind of want to do my override toString. So let me just show you this because it'll come up. It looks a little strange sometimes the way it works. There's kind of two strings. So I can say return curly 0 is curly 1 dot format. All right, come back here. Dot format self dot name self dot age. Yeah. So coming from .NET, you're like, oh, that's gonna fix it. No. If I did this, I said print people of 0. Yeah, it's 21. But in these larger object graphs, it says I'm trying to show like an object representation of the thing, not just a string version of it. So there's a separate method here called representation. So repper or reaper, you'll sometimes hear people call it. So under string. Okay. So now if I run it, here we go. So these are our people. Let's do some LINQ on them. Right now we've got a set of people. I think the most natural question to ask is who are the partiers? Like, who here could be old enough, at least in the United States, to go drinking, but not so old that they'll go to bed at like 9 o'clock? So I'm kind of thinking that's like between 21 and 35 or something like that, right? So what we can do is we can go over here and we can say P for P in people. If I spell it right, in people, if P dot age is greater than 21 and P dot age is less than, what did I say? It's 35. Okay. That's right. So let me just go over here and say print partiers. Zoe 30. Let me add somebody else. Oh, of course, equals. Right, so we get Jeff and Zoe. Right, now, what does it want to do? Yeah, okay, that's fine. Okay, so this is a little bit like LINQ. One thing that we weren't doing is we weren't doing a projection. Like in my example with the anonymous type, I was able to select out something. So I could just say p.name, show me the name of the people, and there's Jeff and Zoe. I could do a transformation of it. I could say like uppercase them. Is it upper? Yeah. So we can get their uppercase. I could even do the anonymous object. I could say anon object of, say, name equals, let's call it a nickname or something like that, equals p.name. Okay, and it says you need to import that from above. Sure, that's from our other module. Right, so here's our actual object, and I can come down here and I can say print first partier curly zero dot format is going to be partiers of 0, that's the first one, dot nickname, right? First partier is Jeff. So this is very similar to LINQ. We've got our projection, we've got our looping, we've got our where. The ordering really should happen in a different place. So at the end I need to say partiers.order, sort rather. And you just say what is the field you want to sort on. So I can say I want to sort on, given a lambda that takes a person, they go to ts dot, let's sort by age. Yeah. Right. Oh, whoops. What did I do? Unsortable type. Oh, well, because I did this projection, all that's left is nickname. So I guess we're going to sort on nickname, right? But I could select their age or something like that, right? Could also add. Let me add age equals p.age. Then we can sort on age. So we got Jeff and Zoe. Still Jeff and Zoe. Let me sort on their age in reverse. Got Zoe and Jeff. There you go. Right. Of course, it wants us to shorten that up. All right, so it's not quite as elegant as LINQ, but if you go back here and you look, you'll see there's a lot of similarities. You just have to like scramble your brain up a little bit and say, you know what, everything is in the wrong order. So the where statement goes here, the order by goes there, the projection goes there, and so on. But basically, you know, you have LINQ, right? Something very similar. Now, the other thing that's awesome about LINQ is it gives you this power to access all sorts of data types, right? Like you could have people be a database, you could have people be a NoSQL database, you could have it be, you know, Twitter with link to Twitter, things like that. You don't really have that here. This is more like you have linked to objects, right? So in that regard, you know, definitely a hat tip to C# and that they've got something great. Okay, so another thing I already talked about it, NuGet is pretty awesome. So here you can see if I wanted to talk to MongoDB from C#, I go either to the UI or I go to the package manager console and I say install Mongo C# driver. I don't have to have the version if I don't want. And it'll suck it down, add reference it, configure it to run, all of that stuff, right? So in Python, you have something very similar. Like if I want to talk to MongoDB, let's go over here. We'll say, import's not going to work. We'll say NuGet. That's what we'll call it. Keeping with my thing here. So suppose I wanted to work with PyMongo. You can see there is no PyMongo, or if I want to talk to MongoDB from here, it's super unhappy about this. Try to import it, goes, no, don't know anything about this. Just keep trying again. So I can go over here to my Python interpreter and configure this interpreter, and I can say, you know what, I want to install PyMongo, which is right here, and that will download it and install it. But I can even do better than that in Python. I can create what are called virtual environments, where only it's kind of like a localized copy of the runtime for your application. So imagine that .NET wasn't this enormous thing that just got installed and like took over Windows, but was a folder that you could kind of work with and manipulate and didn't require all that registry stuff. Right? So Python is that way, and there's this thing called virtual environment. So I can go over here and say virtual env like this, env, which is here. So here's something that's kind of like from NuGet. So I can say install, and you'll see that it's, if I get this out of the way, it's installing up there. So now we have a virtual environment. And once I have that, I can go over here and say, yeah, I can create a virtual environment. And let's see, where do I want it? I want it in Python / LIDNUG environment, something like that. We'll just call it that. And what interpreter do you want? You can pick a different one, and it'll set this as a thing. So then it goes and it creates like this local copy. So you can work only with the dependencies that your project needs and not what's installed in Windows or the Mac or whatever. All right, so just into this little bit, I can say I want to install PyMongo. Install. And do I have MongoDB running? I believe I probably do. Let's see what I got. Bookstore, okay. All right, so that's installed. That's cool. Let's go over here. So that was just like NuGet, right? Now you can do this. I can say PyMongo. It says, oh, you need to import PyMongo. Okay, cool. So I'll say dot connection con equals that. I'll say db equals connection dot bookstore. Check out the anonymous typing. The collection equals db dot book. I think it's called book, and we'll say collection dot account, something like that. Let's print that out. Not sure if it's going to run or not, but we'll give it a shot. Run. Boom. There are apparently 271,000 books in my bookstore. You want to know what the first one looks like? Collection dot find one. Okay, the first book apparently is called Classical Mythology, right? How awesome is that? So you go out there, boom, I want to use this library or this database or this web service or whatever, and you just install it. Just like NuGet. Very nice, very easy. And we even created this virtual environment to isolate things. Okay, so moving along. I want to make sure I get to some of the things at the end that you guys have asked about as well. So you can run this thing called pip, PIP, for Python install package. To do this, just like you can do the install package from PowerShell, or you can just use the UI in PyCharm. Notice, I don't think the Visual Studio one has such a UI. Now, NuGet's pretty awesome, right? They've got, I think they're like up to 18,000 packages now. So there's a similar place called PyPy, P-Y-P-I, Python Package Index for Python, and they have, I think, 38 or 39,000 packages right now. Okay, so all the stuff that's awesome about NuGet, there's even more of it over here in the Python world. So one of the more unknown features of .NET, introduced in .NET 2, is this yield return keyword. And it lets you do some really interesting things. Like, here's all the Fibonacci numbers, all of them. The infinite series of Fibonacci numbers. These are them in this little code here. If you try to put that into a list or an array, you're going to run out of memory. Right? This will let you just stream them back and consume them until you're tired of looking at the Fibonacci numbers, then you stop. right? You could break out of your loop or whatever, your for each loop. So could we write something like this in Python? The answer, of course, is yes. Let's go over here, new Python yield. Okay, so def fib is going to be a function. It's going to return all of the Fibonacci numbers. Let me just do a pass on how we're going to do that for a minute. Let me just do a for loop. So I'll say for f in fib if f is greater than, whatever, 200, let's stop, break. Otherwise, I'm going to say print f with end equal to that. Okay? So let's go ahead and do something here. So how do you implement this? Well, we're going to have this current value and this next value. And these are going to actually be defined to be 0 and 1. So here's a funky statement in Python that lets you basically create what's called a tuple and then project it onto some variables. Right? This is actually what was happening in that for loop we saw earlier with the index. So here I'll say while true. Then I want to say current comma next equals next current plus next. I'm using nxt because next is a reserved keyword in Python. Okay, and I'll just say, where do you want to start? You want to start at 1 or 0? Yield current. Okay, that's pretty crazy. Do you think it's going to work? Remember, the output should be 1, 1, 2, 3, 5, 8, 13, right? Summing them up. Let's try it. So run yield. Ooh, there's your Fibonacci numbers up to 200. That's all of them. If I didn't want to stop, right? If I just want to let this go, I'm not going to. But if I wanted to, I could just let it go and it would print them all out. It would just run out of time to try. All right, so here's the C# implementation. Just to show you how clean and nice the Python language is, there's the Python version. You guys have seen this over and over, like here's half of the amount of code that you had to write to do exactly the same thing. It's not like you had to give up something to get this, right? Very, very nice. Okay, getting to the original question about web stuff. In .NET, sort of the current cool way of doing things is ASP.NET, especially ASP.NET MVC. In my mind, that's the choice you make right now. Over in Python, you have a couple of choices, actually, some really good ones. You have some that are super well established, and you have some that are kind of the up-and-coming, what the cool kids are doing, I suppose. So Pyramid is kind of sort of my current favorite, and this is like ASP.NET MVC. It's a model view controller. In fact, they're all model view controllers. Pyramid and Flask are related in that they're both what you would call a micro framework, very much like Node.js, where you start from nothing and you're like, okay, I need a little bit of this and a little bit of that, a little bit of that. Give me a little bit of templating engine. Give me a little bit of routing, and you just bring it together, right? You don't have anything that's unused. Django, on the other hand, is sort of more, it's almost a little flavor of SharePoint almost, but much more programmable in that it's also a model view controller, but it has all these like apps you can plug into it. So if you want a way to like do CRUD management of your data that's back-ending this website, you can just install the admin app, and now you've got like a data grid you can work with to manage your data. It comes with an ORM. It's very similar to Ruby on Rails, actually. It kind of comes with its own ORM and things like that. So if you look at who's using these things, I'm going to mix them up, I'm sure. I don't have the separation, but just people who are writing web apps in Python, either Django or Pyramid. Dropbox, I believe YouTube was originally done with that. Reddit, Dig. Probably one of the bigger ones these days is this place called, this one called Discuss. Did I spell it right? Yeah? Nope. Below, oh, there it was. Of course, I misspelled it there with a Q. So these guys used Django, and they wrote this cool blog post, scaling Django to 8 billion page views per month. They do 45,000 requests per second on Python. So there's often a question like, oh, Michael, isn't this Python stuff slow? Like, it depends what you're doing. Are you doing scientific computation? Maybe it's slow, maybe it's not. Are you waiting on a database and waiting on a network? Then it's plenty fast, right? Like if you can run 45,000 requests per second, I can tell you I've never written an ASP.NET site that runs with that much traffic. I wish I had the opportunity to, but I just haven't gotten there. So that's pretty amazing. And so there's a lot of interesting things you can do here. Sorry about that. Jumped around. Okay. So these are all really neat. Let me just go create a new project really quick for you guys. File, new project. This is a project from scratch. So notice I can choose Django, Flask, or Pyramid here. Okay, and I'll just call this, well, let's call this sample pyramid. Okay, this is going to take a second for it to generate all the pieces, because it's going to go to basically PyPy. What is NuGet? It's going to suck down a bunch of stuff that it needs to run, and it's going to take a moment. So you can see it's installing PyPy or Pyramid, which is actually going to what would be NuGet and getting it and doing some work. So this takes a moment. We'll come back to it. All right. So let me keep going for a minute. We'll come back while that's installed. All right. So these are both really neat ones. Pyramid is definitely a good, solid, sort of MVC, clean, lightweight thing. Flask is the up-and-coming one. I don't know of a single website that you would go, wow, that one runs on Flask. Maybe there is one, but like if you look at who's using Flask on the website, it's totally underwhelming. But I've talked to a lot of companies, some big that you would know of, that I probably shouldn't say their names, that are doing really cool stuff with like internal sites and so on. So Flask has definitely got a lot of energy, even though it's not exactly public energy, let's say. So another one that's amazing in .NET is Entity Framework. So they actually have something very similar in Python called SQL Alchemy. And the closest analogy I would give between these things is SQL Alchemy is very, very much like Entity Framework code first. You define your classes, and if you wish, you can define your database from it, or you can just keep them in sync with your database. And you do queries by making statements about your classes, not by writing SQL. So you don't use the same, what we call the list comprehension, the link-like syntax. You just use the SQL Alchemy syntax, but it feels very natural to Entity Framework. So let me pull that up. Actually, I had this open because I thought that I had the right code on this machine, but it was on my other machine, sorry. So let me just show you how you might define some of these things, because it'll take too long to do it from scratch. So here's a class. It derives from our entity base, and it maps to the table of users, and it has an auto-incrementing primary key ID, and it has some other things, right? So that's pretty cool. And you come over here and just new it up to the same style of applying the values, kind of like that dictionary. So here's a user, and then if we want to call them, if we want to save them, we just basically go to this thing called a session, and we call save on it. So let me flip through. So here we've created our user Ed, and this is like your data context in Entity Framework. And instead of calling add object or whatever, you just call add, and it knows which table that goes into, and so on. And then you can do queries on it. So I can say query of user, filter by name Ed, give me the first one, or loop over them, or so on. Right, and it gets it back. So this is going to the database and getting it. Now this sort of syntax here is string-based somewhat. It's kind of icky. Let's see if I can find you the better one. Dun, 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 dun. Yeah, sorry I don't have this. I had it all set up, but set it up on the wrong machine. Yeah, this is much better. Like so, for example, see this? Go to the queries and order by user.id. Right, so it's very much like the fluent syntax of link. So you say dot where, dot order by, descending, and so on. Okay. Anything else to show you? Not so much. But basically, it's a really nice. Yeah, here you go. So give me the users where the name is Ed and the full name is Ed Jones, right? And then you just for each over that. Very nice. Okay. So we probably have Pyramid installed by now. It's still indexing, yes. And it says there's some more requirements. This is why you want to have PyCharm and not Visual Studio. So we need this thing called a debug toolbar. And let me just open this up. All right, so notice we'll have templates. There's this templating language. The templating language is somewhat like MVC Razor. In some ways it's less good. In some ways it's better, actually. So there's some really cool syntax you can do here. We can do tal.condition. Then I can just say, you know, I only want to show this if $ is admin, something like that. So if I had something in my model that I was passing in, actually I think I might have this. I might just need this. Anyway, if I had something called isAdmin that was a Boolean, this thing would either show or hide completely on this. I don't have to put like a if loop around it like you do in Razor. So in that way, it's better. But a lot of the other stuff about, you know, pulling out values is kind of not as clear as the other way. All right, so I think we're good to run this now. Oh no. Yeah, hold on a second. So I believe the problem here. Open this in Explorer. I think there's a space in my, yeah, definitely that's the problem. There's a space. So let me just put this on C:\\. And let me open it up again. It doesn't like it if there's spaces in the directory structure where you're working with it. Okay, so let's try one more time. Be happy? Run. Of course, now I gotta go set my properties again. So we can go to our, easiest to do it like this, edit, go down here, and this will be not this long one, that was the problem. By the way, this is super hard to debug the first time you run into it. And I want the virtual environment there. Okay, I think. Or maybe I want the other one, sorry. The configuration, where did it? Oh yeah, so one final thing is this uses like a packaging structure. Develop. Set up task. We need to run this thing here. Maybe the working directory is off. Hold on. Directory no. Not sure this is doing what we want here. No, it's running the wrong one. Let's switch over here. Sorry, guys. What's going to do? Okay. So I have to go to the command line. So you basically have to like say, look, this thing normally gets deployed as a package, but I want to run it here. Where's my thing? I need to run this really quick. I think I might be running the wrong interpreter too. Hold on. Let's run that one, yeah. Be here. Sample pyramid? Okay. I don't know what's in here. Did I set up? So I want to do Python set up .py develop. Not sure what went wrong with the IDE, but that's all right. So you can see it has to basically install these packages locally. It's kind of a pain to get pyramid set up and moving, but give it a moment and we'll keep going. And this is probably the last thing I'll be able to show you. So while that's running, let me just see if there's anything else I wanted to show you on my slides. Oh yeah, so JIT compilation. By default, this is an interpreted language, but some parts of it are written in C. Right? So like SQL Alchemy, the really high hotspots of that thing is actually implemented in C, so it's very fast. But if you would like to have a JIT version, you can use this thing called PyPy. Or if you want to run on top of C#, you can use IronPython and consume .NET classes as well as provide Python classes to .NET. Python is the same thing for Java. And you can also build GUI apps. Right? So that's pretty much the things I'm going to talk about. And this is still running. Okay, you can see it's actually trying to do the C compilation. Here, there's a whole series of dependencies that sort of cascade. Okay, so Python, as you saw, is a super clean language, really nice to work with. So many of the things about .NET that you think are great sort of show up here in Python as well, right? Not one of the things was, radically missing from our list. And sometimes they were nicer, sometimes they were less nice. Okay, final thing, I think I can show you our little web app here. Let's try one more time. Hey, look at that. Okay, so it should be running over here. It is. Oh no, I didn't click the link. 6543. What are those? I can tell it to launch this by itself, but I forgot to. So, dun, 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 dun. This is not going so well for this guy, is it? Okay, well, maybe I won't be showing you Pyramid today. I'm sorry. I thought that it would be, no big deal to run, but apparently it's not really like
much fun if the demo gods didn't show hand, then was it?
I know. Let them know. Yeah, but so basically, you've got this. You can define these little methods. You put attributes on here to say, here's my template. You have this templating engine. What you pass off to the template is a dictionary or an anonymous object. And it's not super different than .NET. The routing is a little bit trickier because you've got to point them at each of you. But other than that, it's really quite nice. Like I said, some big websites are doing it. So, with that, I think I'm just about out of time. Right, Peter? So maybe I should see if there's any other questions before we move on.
Yes.
Well,
you've got 3 minutes. I mean, we don't mind you guys going over slightly if you've got some bits and pieces you want to cover. But come on, guys, you might not get another chance. So, Python questions, bring them on. And I've got a hell of an echo there.
Sorry.
None? No questions? No, but it would appear not. Well, so on that point then, I think we'll thank you once again. Oh, hang on, we have one. There we go.
Ah, yeah. So now they're coming in. Excellent. Thank you, guys. Everyone else who might be taking off, thanks for coming today. Have I ever used Bottle versus Pyramid Django? Not too much. I mean, I've done a few small things with Bottle, and Bottle is another one of these sort of micro frameworks. It does not bring very much to the table at all. No strong thoughts. I would say definitely it's more in the Pyramid side of things, less in the Django side, because Django is quite heavyweight in that it wants to impose its ORM on you. It wants to give you all these apps that are sort of built into it and so on. So it's more like Pyramid or Flask. So what apps are people commonly building with Python? So probably the biggest one are websites. Running websites in Python is super easy. You already saw we can talk to MongoDB. You can talk to SQL Server or SQL Alchemy or Oracle or whatever, or MySQL, even SQLite. So that's probably the first one. But there's a bunch of others. Dropbox is almost entirely end-to-end, including the client side, implemented in Python. That's pretty awesome. You can build Windows EXEs. You can build Mac.app files. So you can build GUIs. You can build these things that are like real apps. I was talking to a company yesterday that is building sort of, for their huge company, they've got like hundreds of products, web apps and services and so on, and they're building it like an entire sort of like cloud storage system on top of Python that all of their other apps are going to be consuming. So that's pretty cool. You don't see a toolbox. Yeah, so you're thinking like ASP.NET MVC, not MVC, web forms, right? I see, where you do like a draggy, droppy thing. No, they don't really have that. If you're talking about like GUI apps, there's one for that, but it's not built into PyCharm. You got to sort of do that out of band, kind of like you do with with Xamarin and Xcode, those kinds of things. But if you do Iron and Python, then you could have you just use Visual Studio. You're welcome, Mario. Thanks for saying so. Good question from Humberto. In my experience, what are some of the reasons that .NET developers hate Python? Well, I think the lack of typing kind of freaks people out, and you can see my C# traciness leaked in there and I had a semicolon. You can write semicolons, it just ignores them. So why do you hate it? I think, the building Windows apps and GUI apps still is quite a bit better in Windows, right, in Visual Studio, and that's one of the things that might drive you crazy. It's not impossible to do refactoring and type discovery and stuff, but it is more difficult to work on large apps compared to C# because it's less clear what you're getting past. Typically you make up for that with unit tests and code coverage and things like that, which this is all built in. Like if this was a set of unit tests, I could go run my test or run it with code coverage and things like that. Okay. I think the interpreted stuff at first freaks people out as well, right? But once you realize that actually a lot of the high performance parts are written in C, then it starts to feel a little less weird and you have a lot of different choices as well. Good question. Can you repeat when one would use Python versus C#? Sure. So I would use Python if I'm doing something cross-platform, period, right? I mean, you do have Xamarin Mac, and you kind of have Mono, and it works pretty well, and so on, but it's just not clearly, this is like clearly supported across platform. If I was building stuff in the cloud, like web apps in the cloud or something, I very well might choose Python because you can use Google App Engine, which is super cheap. I think they give you up to 1 million page requests per month for free, 100% free. You could use Amazon Web Services and choose a Linux instance, which is cheaper, for example. That's a good one. How do you use it to connect to .NET? So can you only use Iron Python? I would say that's really probably the only reasonable way to connect them. Like there are ways to do C extensions, and then from C you can connect back to .NET, but that seems a little bit like a Rube Goldbergian crazy, the doll kicks this thing, it rolls down the slider, and then it knocks over the sheet, pulls down the sheet off the bed, which starts the fan, which then, calls the method, right? That kind of stuff. I wouldn't go down that path. So probably Iron Python, yeah. Or services, right? If you're going to run them as web services. So Peter says, we see Python used a lot as a language to add user scripting to larger apps. Yeah, and that's a really good use for Iron Python too. A lot of people are hosting Iron Python in their .NET app and letting people script their .NET app with Python via Iron Python. That's pretty awesome. Now you can expose like your API to Iron Python, which goes out to Python and so on. So are there any toolkits for something like my huge C# game to allow me to script the game? I don't know if there's any toolkits, but I know there's some good things, some good resources for hosting Iron Python as a scripting engine in a regular app. So I would start there. I'm not sure if the game is written in .NET, right? That's kind of a big assumption. Okay, last one. How do I write unit tests in Python? Okay, so let's write some unit tests. Let's go over to our person. Where are we? What do they call it? Link. that the best one to play with? Yeah, it'll be fine. So we come in here to define a class, which is a person tests. It derives from test case, which we have to import that, right? Down here that we have a def test something, and here we'll just say self.assert. Yeah, search almost equals, say 1, 2. Okay, so obviously this is going to fail or whatever, right? Come down here, run unit tests. Boom, here's your unit test running. Of course, it ran the other code too. You really wouldn't put these together, but check this out. Failure, assertion error 1 is not equal to 2. Okay, so you would have this, of course, in its own thing. Let's go over here and let's just say we'll have a person, P equals person of, what's a name, let's go with Jeff, and what was he, 21. I can say, let's suppose person has a method that goes check can party or something to work with our example that we had before, okay? So we can add that method over here, and we'll just say print, let's just do this, we'll say return self.age is greater than or equal to 21, okay? So now down here, let me comment this out for a minute. Let's go run my unit tests again. So, I guess I didn't copy enough out, did I? So it says, what happened to it? Definitely didn't seem to like it, but did I comment all of them? No. All right, one more time. Hold on. Run unit tests. Doesn't seem to like what I'm doing here, but it definitely does not want to tell me what's happening, does it? But I guess I could debug it. It's possible that it's running in the debugger now. I don't know, guys. So the test passed, but it says exited with code 0. So let's, oh, probably because I didn't assert anything, sorry. Self.assert. Assert is true. Let's assert. R equals, yeah. Yeah, that's why I was, unhappy. Okay. So all of our tests passed, but if for some reason, maybe it was, we had this backwards. All right, you can see, we expected true, but we got false. All right, and the other thing you can do is pretty cool. Sorry, I fumbled around there for a second. Really, it would be much easier if you start your own file, but that's not what I did, is it? So you can come over and say run code coverage. Oh, let me get this thing out of the way. I have to install code coverage. Hold on. Back out to PyPy we go. Okay, now we can run it with code coverage. And you can actually see it shows you 87% of the lines were covered. That's pretty cool. Does it highlight them? Which one? No. I don't think it highlights them. Yeah, but at least it tells you which ones are running. You can do a little export, save me my. I guess I better pick a better folder to put it in. You go over here and generate a report, and if you open up the report, it will actually show you like what code was run, and so on. Okay, it just says all missing, doesn't it? That's not good. Anyway, yes, you can run unit tests as well. All right, George says, is unit test part of Python or an external library? Unit test is part, so this thing comes from the base class library, or what they call the standard library, right? So you can go to definition and actually see what it is here, right? So if we go to the top, right, where does this thing live? Let's show me. C Python lib unit test. So yeah, this is just a built-in class. So the ability to do unit testing is built in, but the code coverage you saw had to install a separate script to make the code coverage work. Okay. Can Python code be compiled as standalone exe like .NET? Absolutely. So if you were going to compile your stuff, you would probably use this thing called cxfreeze. And pretty cool. It's kind of hard to find, so I would actually point you at this video, compiling using cxfreeze, and it's like an 8-minute video that talks you through it. But you get this thing called cxfreeze, and then you just go and add the setup py here, and then you basically run it, say, package up my setup or execute my setup with the intent of creating a binary distribution, bdist option or whatever, and here it'll take this script and then everything that it uses and all of the dependencies that it needs, like PyMongo, for example, as well as the exact version of Python you pointed at, and you ran cxfreeze with, really, and it'll package all that stuff up into just an exe that you can go run. Yeah. So that's pretty cool. And then there's another one called Py2App, which is the equivalent thing for creating a standalone .app file for Macs. So you can do cxfreeze and Py2App, and then you end up with sort of native feeling apps for both Windows and for OS X. All right, that's the end of the question queue. If you guys have any more questions, send them in.
Well, I think we'll call it a wrap there, Michael.
Excellent.
Thanks once again. Another excellent presentation. It's been a while since I've touched Python. The last time I looked at it was programming the Nokia N95.
Oh, yeah.
It was one of the only, in fact, it was the only decent language on there. It was either that or J2ME, and well, I know which I prefer.
Yeah, for sure. So maybe you're familiar with the Qt framework.
Mm-hmm. I am indeed.
Yeah, so one of the things you can do with Qt is there's this thing called PySide and PyQt, which are basically bindings over to Qt. And Qt is a really nice cross-platform thing for Windows, Linux, and OS X. So you can basically write, this is probably the best way to write cross-platform UI things. Right, so you saw me pull up RoboMongo to remind myself what the database was called. This thing right here that I'm using, this is all written in Qt.
Wow.
So if you package it up, so if you package up your app as an exe and you use Qt, here you go. Right, you can build this sort of stuff in Python. This is technically written in C++, but there's no reason that it couldn't be done in Python.
Dimitri's just put a question in there for you.
What is the most used version? Well, 2.7 or 3. Yeah, so it's a little bit weird in that people didn't just jump on to 3 because it was such a breaking change. It's almost like VB6 to VB.NET, that sort of change. Originally, it was definitely still 2.7. It's starting to turn the corner, and if I were learning it from scratch, I would go with 3, just because I would want to, my natural tendency is to want to go forwards, not backwards in sort of technology, but you will find places that certain libraries are still only supported by 2. It's kind of disappointing, but Windows Azure has support for Python, but it only supports 2.7. Last time I checked, I think. Windows Azure Python, I believe so.
Well, what a lot of people might actually be surprised at, if any of you have the Quantum GIS package on their PCs, or the Vector Inkscape package, you've already got Python, the full internal, the full compiler and everything installed without realising it. Particularly if you've got Quantum GIS, you'll find that you have the full installation in the root folder of C:, with all the third-party GIS tools like Proj4 and everything as well.
Yeah, that's excellent. And a lot of the GIS tools basically use Python as their main scripting language. You know, ESRI, yeah, I believe ESRI is one of the main consumers as well. If you just look at Wikipedia, Python, actually it's like right there in the first paragraph or two, they talk about the GIS integration with Python.
Mm-hmm. Well, anyway, thanks very much once again for doing an excellent presentation. I'm guessing we're going to have you back again in the future. I don't think we can keep you away now.
Yeah, we don't know that yet. We'll figure out something. Let me know if you have a request.
Absolutely awesome.
Excellent. Thanks for having me, and thank you everyone for coming.
Great stuff.
All right, bye all.